Okay, so the last part, part 6. A melon is said to be superior grade if its mass exceeds m kilograms, if at least 10% of the melons at the fruit store are deemed to be of superior grade. Find the largest possible value of m, giving your answer correct to one decimal place. Okay, so what is this asking? It basically means, okay, at least 10% of the melons at the fruit store are determined to be of a superior grade. So if I have my normal distribution here, right, there we go. And so I actually can put some numbers to this. This is 0.8 kgs, right? And I have some value up here. Let's call it A. And I know above A, sorry, not A, I actually know what this is. This is M. If its mass exceeds M, then it's superior quality, and I know at least 10% of the melons have this mass. So what does that mean? That means I know the probability that my random variable x is greater than or equal to m must be bigger than or equal to 0.1. Well, let's turn that around. That means that 1 minus the probability that x is less than or equal to m is bigger than or equal to 0.1. Or, in other words, that the probability that x is less than or equal to m is less than or equal to 0.9. So, what do we do? Well, we remember x is normally distributed with a mean of 0.8 and variance of 0.2 squared. So we can use our inverse normal on this. There's no need to standardize it this time because we know both the mean and the standard deviation. So I'm going to go to my GC and I want to use the inverse normal command. And the area that I'm looking at is 0.9. And I know my mean is 0.8 and my standard deviation 0.2. So I key all of that in and I get 1.0563 or 1.06 to 3 significant figures. So I know that this value up here, m, is from GC. If it was equal, m would be equals to 1.06, but is it equality that I'm after? No, I'm not after equality. I'm after the inequality, that m must be less than or equal to this number, because any bigger, if it was bigger than this number, then I would have more than 0.9 below it. So again, just try and logic it out. If I made m bigger, right, then I would take up too much here and this would become smaller than 0.1. I need to go this way a little bit. So m must be smaller than what happens at this line, and this line here is 1.06. So the largest possible value of m to 1 dp is what? Is 1.0 kg. Why 1.0? Because it can't be 1.1. It must be strictly less than 1.06. So the nearest one, the largest one, is 1.0 kg. So any questions on part 6 or any of the parts in example 8, please just leave a comment in the comment section below.